Hey everyone, I'm Mark and this is Mosen. We're going to talk to you guys about a project we're working on right now in Canada. And I'm not going to talk a lot about ontologies and architectural vernacular, though it is important that the whole concept of why we're doing what we're showing you today is to actually capture states of the building throughout construction over about a 20-ish year period. So everything you're going to see today has been done with UE 5, 5.1.
5.01.
5.01.
Yeah.
And there's a lot of reasons why we don't advance to the point releases because of certain ways that we're doing things and the way that we're ultimately scaling what we're doing and will distribute it to a broad and diverse group of end users. So I'm going to give you some context as to what it is we're doing. Mosen's going to talk more specifically about how we're applying reality capture content through the design process in meetings with the client. So really at a high level, the goals of all of this are to essentially preserve the local state of the building's design and to be able to have a conversation and a dialogue with the client to more discreetly understand what it is that is of value to them and where their kind of interests lie in terms of where they desire intervention or not. And, you know, in order to do this, we need to essentially capture throughout several states of construction what how the design progresses. In parallel, there's an active ongoing effort to essentially conceal and unconceal elements of the building. There are aspects of the building that cannot be removed, so we have actually built-in elements that need to be preserved and captured, but we also have what we call removable elements, which become detached from the building and go off-site to a remote location. Now, a lot of this has to do with multiple different hands in a very diverse pot of skills. Essentially, what we're looking to do over the life cycle of the building is to capture pretty much almost everything we can to some degree. Now, this is a building, this is Canada's Parliament building. It's the name of the building is Centre Block, so there is an east and a west block. There are two buildings that flank this on the property, and you saw in the initial video kind of where this building sits in the center. The original building was designed by an architect in late 1800s, but was not originally built until early 1900s. And these are just some photos of what was going on at the time. Today, we're actually building a new building on the lawn underneath the existing building, which sits on top of bedrock, which is obviously requires significantly more technology. Now, again, here's a view of kind of what is called the Peace Tower. One of the major design interventions you're seeing here is currently the building on both the left and right sides where you're seeing a ton of glass is open to above. And we're proposing to enclose those moving forward. Now, what's kind of critical in this exercise and why reality capture plays such a huge and important role is that when we did an early analytical assessment of all of the different types of content that we would have throughout this process, we determined that there was really no single source of truth for some form of geometric representation that existed. So essentially, if we had an entire row or column of Ys, that would have been a great thing, and that would have identified for us, let's say, that the solid geometry is the governing factor. But what we ended up with is that we found that in all of the different types of implementation and the people that would touch this thing versus the formats that were available to us, there was no governing format. So the problem for us is essentially to harmonize and unify all of those different content types into what I guess you could suppose call a platform. So what we did was we did a somewhat exhaustive analysis of all the different types of assets we would have. In this case, I'm referencing a door assembly, but there could be window assemblies and all other sorts of elements within the building. The point here and the takeaway is that there are sorts of groups of data and information that exist for us that are driven by asset databases that exist throughout an asset's life cycle, but then also find themselves into some sort of deployable app. So for us, we use the information amongst a large, diverse team of around 500-ish people, and everyone has their own unique use case, which can be difficult and problematic at times. So what we found after doing these series of assessments, and I'm going over this, by the way, at like high speed and at a very high level. There's much more, obviously, to the whole process. But what we found was at the core of all of these technologies, where we could unify all the different data formats, would be in a game engine. And so we did an assessment of competing engines. And as it turned out, Epic, and I'm sure you'll hear this through a lot of stories, auto, aviation, what have you. I mean, we certainly heard it in the keynote earlier, was that Epic is exceptionally supportive when they see and identify new use cases that they may previously not have been in those existing markets. So for us, what we found was we needed this kind of centralized element to harmonize raw data, geometric data, reality capture data, and construction-related data. So stuff that was happening just in time, live on site, right? These are all of the different sort of challenges we have, and we have many different end cases or endpoints where we need to deploy all of this in real time. So for us, the key aspect of all of this is to maintain the continuity of the data throughout an asset's life cycle. So as I was mentioning before, we may create a point cloud scan, we may remodel in mesh geometry or solid geometry an element or aspect of this building. We certainly are for our architectural purposes, but what's critical is that as an asset exists and it becomes geometry or it isn't geometry, whatever form it's represented in, we need to be able to correlate the geometry with a visual representation of that asset. And so in some cases, we don't even have geometric representation of an object, so we actually use a bounding box, but we tie the data to that bounding box so that as that thing exists throughout time, the data is still associated in context and geodetically aligned with a place. Now, I'm just going to shift over now more explicitly to some of our processes here. So one thing to understand is that we are going into the site. So there's a dedicated team of individuals that are daily scanning. So week by week, they basically sit down as a group. They determine what it is they're tackling this week for scanning, which all involves coordination with the construction schedule. But the team goes into the building essentially every single day to scan a new space and a new room, right? So as things are taken apart, so demolition occurs, we expose services, we scan those services. As those services are removed, we scan the base building behind it. As we start to put things back in, like framing, insulation, that gets scanned, right? So we have a layer by layer compositional analysis of the actual project as it occurs, right? Which we can align with all of the design models as we proceed through the different phases of construction. Now, a great deal of this, and you're going to see some numbers now, like 80 terabytes and what have you. Thankfully, Epic isn't the only one innovating in the realm of reality capture. There are some other companies that are doing some really powerful things that actually integrate really well with Unreal Engine, which is enabling us to be able to do this, right? So as I mentioned before, we have a team of about 400 active designers, engineers, architects, mechanical, structural, electrical, plant ops. They're all simultaneously working, referencing the reality capture content live in Revit, which is also streamed to UE, which is what we're here to talk a little bit about today. In addition to that, we have a significant amount of photogrammetry, just super high resolution photos representing an asset. And we did that because there are certain elements that have been identified as critical assets within the building. So they need to be or have an exceptional level of detail associated with them. So we're using the point clouds and the photogrammetry together to create super ultra high resolution textures. In addition to that, we're using hand scanning for sub-millimeter accuracy for some of the elements of the building. So what you'll see if you were to go to the construction site, you'll actually see them pulling off giant pieces of stone from the building, putting them on these skids, these wooden skids, to be able to have the team go ahead and hand scan some of the refined elements, which we then go and we geodetically align back to geoposition with our 0, 0, 0 for the point clouds. On top of that, as if photogrammetry wasn't enough, we have ridiculously high resolution orthophotos. So what this does is that when we remap, as you'll see some of the stuff we're doing, when we remap some of these textures, we're talking like 500, 600 megabyte ceiling textures, right? At 48,000 pixels or something like that in some of these cases, because if anyone's ever done photogrammetric photography and created a mesh from that, what you realize is that one of the key aspects of all of this is lighting. If anything is poorly lit, when you basically unwrap a texture, it just looks like it's got spotty, dirty marks everywhere, and it's junk, right? So we need to be sure, and this is what the composition looks like. So this is UE, and so this is what the textures look like when you remap them on the surface after basically layering all of those different types of geometry on top of one another. So again, love the particle physics, by the way, in UE. It's unbelievable. So one of the cornerstones of the site, actually, when you first enter the entire parliamentary precinct, is the flame. And the centennial flame represents all around it all the different provinces and territories in the country of Canada. And it's the first thing you encounter when you come to the site. So it's actually really cool to be able to simulate its operation. So I'm going to talk just a little bit now about some of the things before us. Mosen's going to talk critically about the procedural elements of how we engage with the client. But at a high level, some of the stuff we're going to talk about is a sense of photorealism. The client needs to understand like they're in the place, they need to be part of the design process, and they need to be a critical voice in understanding what the outcome is as it satisfies their needs. So we're not just having to do this, as one endpoint. We don't distribute to a game, although that's part of it. And we'll show you a video at the end, which is our whole pixel streaming deployment, which is like a Kate's architecture deployed to a data center. But we also have things like static renderings, which are, pretty typical in AEC. Then we also have active meetings, which is what Mosen's going to talk a lot about. And we also have, VR and AR, right? So we have elements where we're, bringing a mobile PC, not like the one in the cabinet here, say to site with a Vario headset and looking at things superimposed over a demolished construction site. But we also have some systematic cinematics that we use to help the client understand what the future states or what possibly could be. So here's just a little it's choppy because it's got a low FPS, but this is kind of like some of the things where we're moving around and we're working with the client and we're saying, what if we actually change the seating layout, what have you, the lighting, and so all that stuff's being done in real time. This is you.
Yes.
Now you're gonna hear from Mosen.
So yeah, hi everyone. My name is Mosen, and I'll kind of go into more of the technical aspects of everything that you've kind of seen so far. And also talk about the sort of different methods that we've employed from, game development and with models and meshes and textures and materials and everything. So yeah, we'll get right into it. So this space is the rotunda. I think it's one of the main spaces of the building. It's like when you first enter the building, it's the most central part, and it kind of branches out into the rest of the building. This scene in particular, it was made mostly with nanite and photogrammetry meshes. In this space alone, there's, I would say, approximately 15 to 20 gigabytes of just mesh data alone, along with like 8K textures and all that other stuff. And we had to jam all that in with nanite. If nanite didn't exist, we would not be able to do this on time with these tight deadlines that we also work with. So nanite has been very instrumental and helpful in this process overall. We have also kind of employed custom modeling for things like light fixtures, editing texture maps so that we can clean up photogrammetry models. This would also enable us to change the wood tone and kind of bring back the interpretation of the original architecture's vision into the scene. And this would also enable us to add more material domain into the materials that we set up in Unreal as well. So things like adding a metallic trim around the paintings, We wouldn't be able to do that with photogrammetry because it's all just static materials and images. But when we unwrap the model and we apply texturing and materials to the model as well, we can also do things like metallic masks and change the roughness of certain parts of the texture maps as well to make it more shiny or less or more dull. And we'll go into more detail in the following slides here. So the first step that we go through with these photogrammetry meshes is we do retopology. 90% of the retopology that we've been doing so far in these rooms have been done by hand. We have also explored doing things like remeshing and other sort of methods to make the process a bit quicker, but doing it by hand has given us a lot more control over how the model is represented. And also with some of the photogrammetry meshes, it's very blotchy if you've had experience with photogrammetry meshes. So doing the retopology by hand kind of brings it back more crisp edges to the model itself. And that kind of also helps us with shifting around the model in case there are dimensions that have been changed and stuff like that. And yeah, so that's retopology. That's like the first step. And here we also do bakes of the original material onto the retopologized model. So in this case, the photogrammetry model already has materials applied with the color and everything. And we bake down the diffuse maps and the normal maps from the photogrammetry model onto the retopologized model. In this case, on the right side, that's the photogrammetry model. And you can see there were paintings that were there originally. And they kind of wanted to take them out because they're going to reinstate a new wallpaper. And the new wallpaper is a bit more busy, so they opted to remove those paintings. So that's something that we also did for this model specifically. So this is the older version of the whole process, which is all done in 2D. I believe the person before me before I came on, that was doing this process kind of like took shots of the 3D model or the laser scan and brought it into Photoshop to sort of add like light shafts and stuff like that. And this was kind of a bit like dull, not dull, I would say, but more like it was a bit more of a laborious process than what we have currently. And they were just working with 2D images, so it wasn't as good as working with the 3D models, I would say.
And what I'll add to that is that, you can go to the next slide.
Sure.
Is that ultimately the power of actually using real-time game engine is the procedural aspect of things, right? So blueprints are procedural materials. These are things that happen based on rules as opposed to manual processes that are extremely labor intensive.
Yeah. And another thing that we could also do is bring in furniture layouts from other DCC packages like Rhino or Revit. And this would also kind of put into context the model of the room with the new proposed furniture layouts as well. And this would also give the designers and the heritage architects a bit of a better image of like what the final look of the room would be like. So this was also a pretty instrumental thing that was part of the process too. So yeah, I think here we kind of go through the steps of kind of taking the photogrammetry model and creating a low poly model along with all the materials and stuff applied to it. So the first step here, this is the photogrammetric model itself. So you can kind of see the quality of the model. It's pretty good, but if you zoom in, you can kind of see like how tessellated the geometry is, and there are spots where there's like wiring and stuff that make it very like blotchy, and those are things that were actually asked to be taken out of the final model. So that's something that we had to take into account as well. This is the low polygon geometry, abstracted from the photogrammetric mesh. So this is just hand retopologized. In terms of like poly count and stuff like that, we weren't too, I guess, strict about how high or how low the poly count was, because when we brought it into Unreal, we would, enable things like nanite and stuff like that to sort of bring the performance down. Even bringing something like this in, it wouldn't bring down the FPS by too much. We could still like navigate around the room pretty easily with the lighting and everything enabled. And we didn't have that much of a performance edge. So poly count wasn't too much of a strict requirement with these models, thankfully. And yeah, this is the low poly model here. After that, we unwrap the model. So this is a pretty quick unwrap of the model itself, where we kind of just, since this is just like a single wall and there's not that much, other topology kind of going up and down it, we would just like do a projection of the UV itself, and we would bake down the diffuse map in this case. So this is the diffuse map directly applied from the photogrammetry mesh onto the low poly mesh. And you can see that little box in the bottom left corner is where a box used to be, but was asked to be taken out. So that's something that we kind of had to take out of the retopologized model itself, and we would clean this up in Photoshop or Affinity Photo later on. And then this is the normal map that was baked. And this is the normal map applied properly onto the model itself, so we could see all the bumpiness and all the details from the sculptural elements on the stone and the woodwork as well. And then this is just an example of cleanup that we did on some of the texture maps too. So things like the green background was asked to be removed, so that's something that we had to clean up. There was some plywood. I believe that's where some electrical components used to be, so we had to remove that as well, since we're only showing architectural features in these renders. And this is an example of cleaning up the normal map. So if you go back here, you could also see the green background also had a artifact on the normal map as well, so we had to clean that out. And it's kind of hard to see on the screen, I think, but if you look closely, you can see like brick and mortar marks on the top part of the normal map, and that's something that they wanted to have instated instead of just the painted plaster that was there originally. So this is just a before. This is one of the rooms that we've worked on. Actually a point cloud model instead of a photogrammetry model. But we do have a cloud platform that allows us to take a point cloud model and kind of convert it into an FBX mesh. And that's what we would use to create our low poly model and bakes and everything.
So actually just hold on that one for a second.
Yes.
So actually what's important to understand here is that we're using all of that investment in the point cloud infrastructure to be able to illustrate for the client and go through as like, let's say an initial dry run to say, what are the key elements of this space that are critical to you, right? So we identify the elements that are, let's say, intervened with at some point. So not part of the original building, but identified as elements that need to be redesigned in some way, shape, or form or reinterpreted. And then there are core elements to the building, but we also have to identify certain uses for the space as well, right? So what's the intended, the foregoing use for the space versus what the previous space usage for the space was. And so we do that with the point clouds initially, and then we come back, and as Mosen was showing, like we're revising, say, things like the normal maps, the diffuse maps, in order to get that sense of realism. And then we come back to them with a more kind of finite presentation where they then comment, and we go through this process a few times. So continue.
Yeah. And yeah, this is sort of before and after of how the room looks. So things like the old light fixtures in the ceiling pockets, that was removed. As you saw previously, those green backgrounds on the wall were also removed as well. And the wood tone was also reinstated to be the original color as well. So you can see how all this kind of comes together in the end. We also work pretty closely with the lighting consultant on this team in order to bring their vision of what they want to have showcased in the model. So things like adding rectangular lights, point lights, spotlights all around the scene to sort of mimic what they have in their own software called Dialux. Dialux is kind of a software where they do it more for lighting calculations, so it would show things like how much lux you have in the room and stuff like that. Unreal Engine isn't as accurate, I would say, as their software, but we were able to work pretty closely with them to get a very accurate representation of what they have in their own software in Unreal.
Can I just get a sense of who we're talking to here? Has anyone in the audience ever used Lightscape or Radiosity? No? Oh, okay. We got a couple. So I come from an era when what you were describing with Dialux, where you might do in like Unix, right? Using octrees and stuff like that. Well, now they have desktop radiance, but originally developed by Berkeley, where you would have clusters of Unix machines doing these sorts of things. Now we can just click a button. And I think what's important though about UE is the fact that you can still attach things like IES webs, right? So you do still get somewhat realistic dispersion of the actual lighting and how it gets distributed to surfaces, but it's not an analysis software, sir.
Yeah, exactly. And now we're going to sort of go over materials and how we were able to create some pretty interesting materials to help with kind of finalizing the ideas that some of these heritage architects had for the rooms themselves. So you can see on the top and bottom, these are two different interpretations of how they wanted the final room to look. One of them has more of the top one has more of a light brown color to the wood throughout the room. And on the bottom, it's more of a darkish, stain across the wooden elements across the room as well. So yeah, I'll kind of go over into more detail about how that was done. There were some parts in some rooms where we had to model textures themselves. I know we could have done this in Substance Designer, but sometimes we have to do things like this in order to get as accurate as we could to the original wallpaper in this case, for example. There were times where the original wallpaper was sort of lost, but the heritage architects were working with some people that were able to revive the original vision from the architect, and they were able to sort of give us images that we would create models and textures based off of in order to reinterpret or bring back the original vision of the architect's vision here.
We also have some really obsessive creatives working on this project that love to see stuff like this in 3D, which, as you know, if you're into that thing, there's a whole level of realism beyond reality when you do stuff like this, but obviously we can't afford to do that for every space.
Yeah. So this was a texture map from the room that you just saw previously. Has anyone here worked with Alpha Max and stuff like that to create, variable colors, materials where you can change colors pretty easily on the fly in real time and all that? So this is something that we had to do for that room. Basically, we created tint masks. So on the furthest right-hand side, you can see the RGB channels of the texture map itself. And each of those masks control a different part of the wall that that texture is a part of. So I think in this case, the red is the wood elements of the room, or on this wall in this case. The green would be another wood element, or I think it's marble actually. In this case, it's marble. And for the B channel would be the wall colors of this wall, or of the plaster in this case.
So again, we're reverse engineering. This video is going to run. I'll let you speak, Mosen, but sure. We're creating a procedural process, essentially, again, right, to enhance the workflow. Yeah.
And in this video, you can kind of see how we're on the fly manipulating the colors of the various wood, wall, and other elements in the room just by changing material parameters themselves. So this was pretty instrumental in kind of allowing the architects to give us the final decision on which different colors they wanted to have throughout this room. And they were very impressed with how quickly this was able to be achieved. So go next. Lighting. So we had to do a lot of modeling of lighting fixtures and working very closely with the lighting consultant themselves in order to bring the vision of what they wanted in these rooms into the scenes here in Unreal. A lot of the lighting fixtures, all we had to work off of was reference images of the original lighting fixtures themselves. The lighting fixtures did show up in scans, but sometimes they were newer versions of lighting fixtures that were either going to be tossed out or not used anymore. And sometimes they wanted to bring in completely new lighting fixtures into the room. So, for example, the top right image, that's kind of a new lighting fixture that they had proposed for this room. Same with the one in the middle, where it's just a ring of lights to sort of make it as simple as possible. And then the bottom is just spotlights hitting the room themselves so that it wouldn't interfere with other elements in the room. And these are just some more examples of more heritage light fixtures. So these are light fixtures that existed originally in the room, and they wanted to bring them back into the scene and renders themselves. These lighting fixtures do show up in the photogrammetry meshes that we do have, but because of the nature of how they reflect lights, like some of them are very shiny and brass, and sometimes the lights of those light fixtures were actually turned on, which is not good for scanning the photogrammetry models themselves. So we had to be provided the heritage photos of these lighting fixtures and kind of model them again from scratch. And then from there, we would apply materials that would give us like a control on the opacity of the shades, for example, in this case, to sort of bring back the vision that these heritage architects wanted to show for these fixtures specifically.
Right. I guess if you want to just go to the next one.
Sure.
So, anyone who's worked in DCC platforms and, materialization, I guess if you could call it, using like subsurface scattering and these sorts of things, right? These are like technical words that if you do this for a living, you know how all this stuff works, right? But to be able to just dynamically create materials and have a whole library, a stock library that you can apply takes, or it makes this more accessible to a broader array of people to be able to work on this, right? So it's a different kind of content creator and individual that can work with these things, right? To be able to kind of scale it up.
Mm-hmm. Yeah, and these are some examples of lighting fixtures that were modeled from somebody that we've hired recently, actually. And she's done a great job of just modeling the original heritage light fixtures and did a pretty good job of, separating the model so that it's easier to apply materials like a brass material or kind of an opaline glass on some of these shades as well. So yeah.
Leave it here for a second.
Sure.
So yeah, I just actually want to speak really quickly about that because just on the nature of the individuals that work on this project and our team, it's a very diverse skill set. So the individual that Mosen just mentioned, Julie, actually came to us from Ubisoft. So she was actually a game modeler and texture designer, right? We have all sorts of shapes and walks of life. We have like hardcore devs, right, that have done like C++ dev for a living. So the team composition, I think, when you look at everything that's kind of being shown here, you could look at it and say, that's like a broad array of skills. I mean, at a game company or a gaming company, I've never worked at one, but there's a broad array of individuals from like art to modeling to lighting to texture to programming, development. These are all the sorts of skills that we need for this team also. And so those same sets of diverse skills exist on our team in this project as well.
Mm-hmm. Yeah, and then now I'm going to talk about a specific problem that we kind of run into with these photogrammetry meshes sometimes. So this is part of that rotunda space that I showed earlier. That space is built entirely with nanite, or almost 90% built with nanite. There are some parts that are modeled, and this is an example of one of them. So with the photogrammetry meshes themselves, you can't really enable opacity for specific parts of the model. So this is something that we had to sort of fix in order to showcase the outside context of the space. So this is how the photogrammetry model looks by itself. This is the window part. And what I had to do is sort of trim that part out specifically from the photogrammetry model itself, retopologize that part. In this case, I could have done it in a plane, but I wanted to have a bit more control of like how the shadows and stuff interacted with the space. So I modeled just the glass parts of that window. And this is in Blender, so you can kind of see like the wireframe of the mesh itself. And then this is also with the diffuse map applied as a material in Blender. And then here's the asset in UE. So I had to create two materials. One of them has a thin translucent material applied to it, and the other is more of a masked alpha transparency material. We had to do this because there is a certain way in which this glass is actually refracting light in the space, and they wanted to have that showcased in the render. So this is what I had to do in order to accomplish that task. For the mask part, I probably could have modeled the actual, slits of the window, but this was just a bit of a quicker way of doing it, where I could just mask out the parts that had to be completely see-through. And combining these two meshes together, this is the final result. You can kind of you can see the space from the inside, and also you can see the outside context as well. And light shines through pretty well. And also with that, if I go back here, you can kind of see like the blue tints of the window. That was showcased as well, especially within the nighttime renders of the scene. So they were pretty pleased with the final results here with the lighting and everything applied. And this is in Unreal itself with the night mesh applied as well. This is just another example of how UV unwrapping was sort of utilized. So this is another work of Julie, the other modeler that I mentioned, and she did a pretty good job of making it a bit more modular in terms of like how this specific room has been retopologized. So this is a good way of like how she was able to save space on the UV texture space so that we can sort of maximize the amount of resolution that we have in the texture maps themselves. And this is just another image of the low poly model with the diffuse map applied to it. And then this is how the normal map looks applied in Blender as well. Yeah, so very clean, very easy to read and clean up as well in Photoshop or Affinity Photo or whatever image texturing program that we used. And then this is just an example of a ceiling in one of the rooms that we had to sort of bring back the original color scheme for this room specifically. So this is how the room looked from the photogrammetry mesh, the ceiling at least. So with the teal and the beige and everything. So after a little bit of time, we had to clean it up, remove some of the artifacts from the photogrammetry model itself, like where the old light fixtures used to be. And then we also were able to bring back the original color scheme. So they wanted to take out the turquoise completely and bring it back to more of a beige color overall. So this is the final look of that ceiling itself. And then this is the normal map, so you can kind of see the amount of detail the photogrammetry model was able to provide us when it came to applying this into the scene itself. So this is just a before, so that ceiling is part of this room specifically. This is the photogrammetric mesh itself in Blender. And the next slide is going to be the final look of the room itself within Unreal Engine. So you can kind of see like a before and after of the things that were removed, the things that were cleaned up. I believe the room actually used to be a smoker's room. So a lot of the walls were covered in a sort of yellow, overtone. And that was something that had to be cleaned up for this room. So you can kind of see the final look of how much more cleaner it looks now. And this is the final two spaces that we're going to be showcasing, which is the House of Commons and Senate foyers. So this room specifically was done pretty recently, and a lot of great work was done in accomplishing the vision that they wanted to have showcased for this room, from the ceiling itself to other elements in this room, so you can kind of see more of how this looks. So you can see on the floor, the actual ceiling is actually open up to the natural light above, and they wanted to showcase how that will look in the nighttime or in the daytime. So we were able to accomplish this effect by applying specific materials to certain parts of the model, and this is the final result that we got here. It's just another shot of the opposing side here. And this is just some more shots of the other space. This is, I believe, the House of Commons foyer, right? Yeah.
So I think what we kind of want to convey is there's a bit of a mix of, modeling, of course, to clean up the mesh where the mesh wasn't detailed enough for us to use it alone, along with the texturing and the ortho photos, but also that we're trying to rely on that photogrammetric mesh as much as possible to help reduce the burden and workload of manually modeling, right? So there's kind of like this commingling that's constantly existing for us to see where we spend our resources in order to provide the client with real-time feedback. I think that's kind of the clincher of all of this, is that we're not showing it here, but we do have a video at the end. But the idea is that we're revolving around these things in real time in meetings, using this to garner feedback in real time, right? That's, I mean, yes, you can do that with like things like V-Ray RT and what have you, but to this level of realism with this volume of data is really, really difficult to do without a game engine like this.
Mm-hmm. Yeah, absolutely. So this is just another shot coming from just the downstairs here in the middle. So this is just looking up at the ceiling and all the other parts of the second floor here.
Okay,
yeah, pass it back to Mark.
We could do a whole other talk on what we're about to show you next. There's a lot to absorb here and what's about to come and going on here, and I'll do my best to try and talk through it really, really fast as it's happening in real time. But what we wanted to do is we want to give you a sneak peek into all of that stuff we've just shown you, how that gets applied, why we're doing it, and the bigger picture and scheme of things, what role it plays downstream. So we built a game, a binary distributable, well, I can't say it, voice is not working, as well as a pixel streaming delivered solution, okay? As I mentioned very earlier on in the talk, this whole thing runs on a Kate's microservices pod-based infrastructure in a data center, right? So what we're doing here is we're collectively capturing all of the data that exists over time. You just saw some solid models there from mechanical plant ops, right? So it's mechanical, electrical, so you're getting everything from the conduit, the cable trays, the panels, the ductwork, all the architectural elements. So whenever you see like a flat shaded color like a pink or a blue, that's essentially a Revit model. It all gets harmonized here into UE. So a lot of this is driven by the photogrammetric meshes and the point clouds that you've seen. The idea here is you can see the timeline on the bottom. So throughout the course of construction, you can look at what data we have for what room on what level. You can turn on the type of data you want to see. Let's say you want to look at 502S, and right now we're looking at meshes. Now, what's really critical here is on the left, you see that little toolbar that has a bunch of asset identification data. So where does that come from? That comes from actually, as the project is ongoing, we have conservators, heritage conservators going into the building, documenting assets in PDF form, which is a whole other exercise. Like, again, I could spend a whole other time talking about unstructured data and machine learning, but I'm not going there. But that data comes from those people on site filling out reports that then gets attached to the asset geometry or the point cloud, as I mentioned way earlier on with the IFC data carrier, which then finds itself into this application, which gets delivered on web or locally on Windows or what have you. We have a lot of challenges with getting that to work efficiently. I think that doesn't run again, but which I'm happy to talk about offline, not on stage. But yeah, that is essentially in a nutshell what we've been working on, and thanks very much for your time if there's any questions.